Hello, this is Mr. Tobert's class. This is chapter 13, and this is going to be lesson number 2. This is going to be chapter 13, physical science, and it's going to be our second lesson in chapter 13. So when you squeeze a fixed quantity of gas into a smaller volume, the pressure goes up. This is known as Boyle's law. So which means taking up less space means it's going to be higher pressure. And this is the actual equation version of Boyle's law. Here you can see the relationship between the initial pressure and the new pressure, the initial volume and the new volume. Pressure and temperature. As the pressure of a gas is affected by the temperature changes. If you hold the mass and the volume constant, then you will see pressure goes up when temperature goes up and down when temperature goes down. And that's if you keep the mass and the volume constant. And here's just an idea of how that looks, the equation version of what that looks like to solve for it. Pressure and temperature. Anytime we apply the gas laws, the temperature must be in Kelvin. We talked about Kelvin. Kelvin is absolute zero. It starts at supposedly the theoretical zero, meaning there's no movement at all. It is whatever your temperature is in Celsius, and if you add 273 degrees to that temperature in Celsius, that would give you Kelvin. There are no negative numbers with Kelvin. According to Charles' law, the volume of a gas increases with increasing temperature. So as you warm it up, it takes up more space. You warm it up, it takes up more space. That makes sense because it's moving faster. As it moves faster, it can hit the sides of a balloon bigger, makes everything larger. So it goes hand in hand with our temperature. Volume decreases with decreasing temperature. And this is also why hot air balloons float, because the inside is less dense than the outside. And that is the second one there. That is the second lesson for chapter 13.